The odds of discovering an object like 3I Atlas, according to any population model, simply strain belief. If the size estimate holds true, it means either our surveys have somehow missed a vast population of smaller interstellar bodies, or something incredibly rare and unexplained is at play. This is where Avi Loeb's argument begins. Finding a 20-kilometer interstellar object so soon after the first two completely defies the expectations that underpin modern astronomy. The statistical alarm bells weren't just ringing because Atlas was bright. They were screaming because its sheer scale contradicted everything astronomers thought they knew about what should be out there. For Loeb, that single number, 20 kilometers, became the first and most glaring anomaly in a growing list. A mass of at least 33 billion tons now cements 3I Atlas in the record books. This figure, drawn from modeling its movement and persistent brightness, absolutely dwarfs every confirmed interstellar visitor we've seen before it. Yet, this is where the paradox truly begins. Despite vigorously releasing gas at a rate of 100 to 150 kilograms per second, mostly carbon dioxide, there is no measurable change in its acceleration. In comet science, this is a classic problem. Outgassing acts like tiny thrusters, pushing the nucleus ever so slightly off its predicted path. For typical comets, even a little activity leaves a clear fingerprint in the data, a slow drift away from a purely gravity-driven course. But the Minor Planet Center's global dataset, which includes over 4,000 positional measurements, finds no such deviation for Atlas. The upper limit on its non-gravitational acceleration is so low that for its observed activity, only a truly massive object could remain so unmoved. The numbers just sharpen this contradiction. If you calculate the expected push from the gas, it should have been visible in the data unless the nucleus is not only large but also remarkably dense, or the outgassing is perfectly balanced in all directions. Simulations have explored every plausible combination of size and density. For anything smaller than about 5 kilometers across or less dense than water, the math just breaks down. The outgassing would have kicked Atlas off its predicted track long ago. Only a massive solid body fits both the visual and the dynamic evidence. Alternative ideas, like jets firing in perfect opposition, require a kind of fine-tuned physics that seems highly improbable. For Loeb and his colleagues, this isn't just a curiosity. If the mass is real and the acceleration is absent, the door to non-natural scenarios remains open. Thanks for watching, and don't forget to follow for more.